हेलो दोस्तों, मैं हूं तन्मय भट्ट और आपका स्वागत है मेरी यूट्यूब चैनल तन्मय भट्ट में। दोस्तों, हमने सी लैंग्वेज के पार्ट 7 में देखा था कि कॉन्स्टेंट्स एंड लिटरल्स के बारे में। दोस्तों, तो हम इस वीडियो में हम देखने वाले हैं स्टोरेज क्लासेस के बारे में। दोस्तों, तो हम बात करते हैं स्टोरेज क्लासेस के बारे में। अ स्टोरेज क्लास डेफिनेशन द स्कोप and lifetime of variables and or functions within a C program. They precede the type that they modify. We have four different storage classes in a C program: auto, register, static and external. The auto storage class in C programming, the auto storage class specifier is used to declare variable with automatic storage duration. It is the default storage class for local variables within a block or function. While explicitly using auto is optional since it is the default, it can be used to explicitly indicate the intent of a variable. Here are the key characteristics of the auto storage class. Automatic storage duration. Variable declared with the auto storage class have automatic storage duration. It means that the variables are created when the block in which they are declared is entered and destroyed when the block is excited. In the case of local variables within a function, they are created each time the function is called and destroyed when the function exits. Block scope. Variable declared with auto have block scope, meaning they are only accessible within the block where they are declared. They are not variable. They are not visible or outside the block in which they are defined. This is the default behavior for local variables. Initializer variables. If an auto variable is declared without an initializer, its initial value is indeterminate and depends on the state of memory at that time. It is generally good practice to initialize auto variables before using them to avoid undefined behavior. Implement keyword. The auto storage class is the default, so it is not necessary to explicitly use the auto keyword when declaring local variable. Variables declared within a block or function without any storage class specifier are treated as auto variables by default. In the example above, both variables a and b are local variable declared within the main function since no storage class specifier is explicitly provided. They are treated as auto variables by default. The output will display the value of A and B as 10 and 20 respectively. To summarize, the auto storage class is the default for local variables and provides automatic storage at duration and block scope. Using the auto keywords explicitly when declaring variable is optional in C. अब हम दोस्तों बात करते हैं द रजिस्टर स्टोरेज क्लास के बारे में। इन सी प्रोग्रामिंग द रजिस्टर स्टोरेज क्लास स्पेसिफायर इज यूज्ड टू suggest the compiler to store a local variable in a CPU register for faster access. It is a hint to the compiler indicating that the variable will be heavily used and that accessing it from a register would improve performance. However, it's important to note that the register specifier is merely a suggestion to the compiler, and the compiler has the final authority to decide whether to store the variable in a register or in memory. In modern compilers, register allocation is often done automatically without the need for explicit use to the register keyword. Here are a few key points understand about the register storage class. Faster access. By using the register keyword, you suggest to the compiler that a particular variable should be stored in a CPU register instead of memory. Register access is faster than memory access, so this suggestion aims to improve the performance of accessing the variable. Compiler destination. The decision to allocate a variable in a register is ultimately up to the compiler. The compiler takes into account factors such as register availability, the numbers of variables, and optimization goals. The compiler may choose not to allocate a variable in a register even if it is declared with the register specifiers. Limited use. The use of register specifier is limited to local variable declared within a block or function. It cannot be used with global variable or function parameters. No address access. Variable declared with the register specifier cannot be accessed using the address of operator since registers don't have addresses. Talking the address of a register variable is not allowed, therefore you cannot have a pointer to a register variable. Optional. Similar to the auto storage class, the use of the register keyword is optional. Compilers are generally capable of automatically optimizing register allocation without explicit use of the register keyword. In the example above, the variable 1 is declared with the register specifier, suggesting to the compiler that it should be allocated in a CPU register. However, the decision to store 1 in a register or memory is up to the compiler. The loop iterates over the values of 1 and prints them. It's worth noting that modern compilers are highly optimized and they perform automatically register allocation and optimization. Therefore, explicitly using the register keyword is generally unnecessary and may even be ignored by the compiler. To summarize, the register storage class specifiers suggest to the compiler to store a variable in a CPU register for faster access. However, its usage is limited and the decision to allocate a variable in a register ultimately rests with the compiler. What is register? In computer architecture, a register is a small storage location within the central processing unit of a computer. It is used to store and quickly access data and instructions that are needed by the CPU during its execution of program. Registers are the fastest type of storage in a computer system, typically built directly into the CPU itself. The static storage classes के बारे में अब दोस्तों बात करते हैं अब. In C programming, the static storage class specifiers is used to control the lifetime and visibility of variable and functions within a particular scope. It is a storage class that provides a different set of properties compared to other storage classes like auto and extern. When static is used with a variable, it affects the lifetime of the variable and also changes the scope of the variable when used within a function. When used with the functions, it affects the visibility of the function. Here are the key characteristics of the static storage class. Lifetime of variables. When static is used with a local variable inside a function, it changes the lifetime of the variable. Normally, local variables have automatic storage duration, meaning they are created and destroyed each time the function is called. However, when a variable is declared as static, its lifetime extends for the entire duration of the program. The variable is initialized only once and its value is retained between functions calls. Scope of variables. When static is used with a local variable inside a function, it changes the scope of the variable. Normally, Local variables have block scope, meaning they are only accessible within the block where they are declared. However, when a variable is declared as static, its scope becomes limited to the functions where it is defined, but its value persists across multiple functions calls. Visibility of functions. When static is used with a function declaration, it limits the visibility of the function to the current translation unit. A translation unit is typically a source file along with the included headers. Functions declared as static can only be called from within the same source file where they are defined. They are not accessible from other source files during the linking processor. Internal linkage. When static is used with global variables or function, it gives them internal linkage. Internal linkage means that the variables or function is only accessible within the same translation unit. It cannot be accessed from other source file even if they include the same header file. Initialization. Static variables are initialized only once at program startup. If an initial value is specified, it is assigned to the variable during the first execution of the function. Subsequent calls of the function will retain the modified value of the static variable. In the example above, the function contains a static variable called count and a local variable called non-static count. The static variable retains its value across multiple function calls, while the local variable is reinitialized to 0 in each function call. The output of the program demonstrates that the static variable count increment with each function call, while the local variable non-state count always starts from 0. To summarize, the static storage class specifier provides variables with a longer lifetime, changes the scope of local variables and अब दोस्तों हम बात करें द एक्सटर्नल स्टोरेज क्लास के बारे में. इन सी प्रोग्रामिंग द external storage class specifier is used to declare a variable or function that is defined in another source file or module. It is used to provide a reference to an identifier that is defined elsewhere or allowing the current source file to access and use that identifier. When you declare a variable or function as action, it means that the actual definition of that identifier is located in a different source file and the linker will resolve the reference at the linking stage. Here are a few key points to understand about the external storage class declaration. To use an external variable or function in a source file, you need to declare it as external in that file. This declaration tells the compiler that the identifier is defined elsewhere and will be linked there. No memory allocation. The external declaration does not allocate any memory for the identifier. It only informs the compiler about the existence and type of the identifier. The memory for the identifier is allocated in the source file where it is defined. Single definition rule. The external declaration helps enforce the single definition rule, which states that a variable or function can have only one definition in the entire program. By using external, you can have multiple reference to the same identifier without violating this rule. Global scope. When you declare a variable or function as external, it has global scope within the current source file. It means that you can access the identifier from any function within that file. Definition in other file. The actual definition of the external identifier must be present in another source file. This file could be a separate module or part of a library. During the linking process, the linker resolves the reference and links the declaration with the corresponding definition. In the example above, the variable, global variable and the function, external function are declared as extern in the main.c file. Their actual definitions are provided in the external.c file during the linking storage. The declarations are linked with the corresponding definition and the program executes currently. Note that extern can also be used in function prototypes to indicate that the function is defined in another source file. This allows you to separate function declarations from their actual definition. Overall, the extern storage class specifier is a powerful tool for modular programming and also you to use variables and functions defined in another parts of your program. तो दोस्तों आज के लिए इतना ही. हम फिर मिलेंगे न्यू टॉपिक के साथ नेक्स्ट वीडियो में. तब तक के लिए गुड बाय.